Question number 76. Among the following, lowest melting point is of. We have different metals given here: titanium, manganese, vanadium and chromium. 4 metals are given. And the correct order of their decreasing melting point, I'm just showing you. The maximum melting point is there with the chromium. Then there is vanadium. After vanadium, there is titanium. And if we talk about manganese, it has the lowest melting point. And that's why you can choose here option 2 as the correct option. Now, after this, there's another question. That's question number 77. Potassium chromate gives brick red colored precipitate when added to. We have potassium chromate. What's the formula? That's K2CrO4. We should always know that silver chromate is brick red in color. It means if the compound of silver, that is AgNO3 given in the option, is added to this potassium chromate, there is the formation of Ag2CrO4, and this is the compound which has brick red color. Along with that, there is the formation of potassium nitrate. So this would be formed here. Now, on the basis of this, I'll choose option 4 as the correct option. And after this, question number 78. Ferrous sulfate on strong heating gives. Ferrous sulfate, that's FeSO4. In the crystalline form, it is green in color, and on strong heating, it produces Fe2O3, ferric oxide. Along with that, 2 gases are released, which are SO2 and SO3, and that results in the smell of the burning sulfur. It means option 1 you can choose at the correct option, because both sulfur trioxide and sulfur dioxide are given here in option 1. That's why option 1 is the correct one. After that, now here is question number 79. The paramagnetic and tetrahedral complexes among the following are. We have different complexes given here, in which 3 complexes are there of the element nickel and 1 is of copper. Let's identify. So suppose I'm talking about the complex of nickel. Here it is NiCl4 2 negative. And if I talk about this compound, nickel is present there in 2+ oxidation state, if you find out with the help of this formula. The oxidation number of nickel is 2+. So its configuration would be 3d8. This is valence electronic configuration, and it can be represented with the help of drawing the orbitals available for hybridization. Here is 8 electrons which are present in Ni2+, this way. Now it means there are total 2 electrons which are unpaired. And if I talk about this chloride ligand, this is a weak field ligand, and that's why it will not cause pairing in the d orbital. That's why the hybridization occurs here, and that is sp3 hybridization. 1s and 3p orbitals are there. It means hybridization is sp3 in this case, and the shape would be tetrahedral. And in this case, you will see that it is paramagnetic as well as its shape is sp3. It means this is the compound which will show the given characteristic. What's the characteristic? That's paramagnetic nature, and the shape is tetrahedral. Further, if I talk about the next nickel compound, that is nickel carbonide, NiCO4. I'm just writing here, this is NiCO4. And in this compound, nickel is there in 0 oxidation number. It means there is no charge on this nickel, and that's why in this case, the configuration that you can represent here is 3d8 4s2 in this way. 4s2 I'm just drawing here. There are 2 electrons, and empty p orbital is available in this case, in this way. Now what happened here? When carbonyl come in contact with nickel, there would be the pairing of d electrons, and further what will happen? This electron pair which is present in s orbital will also come here, and ultimately it will result in the configuration in which the electrons are filled and paired in d orbital in this way. And now for the hybridization, 1s and 3p orbitals are available. It means this is sp3. But is it paramagnetic? No, it's not, because there is no unpaired electron. It means this NiCO4 is not following this nature. Further, if I talk about next nickel compound, NiCN4 2 negative. If I talk about this compound in NiCN4 2 negative, again the nickel is present there in Ni2 plus oxidation state, and this can be understood in this compound. In the previous one, if you look here in NiCl4, if instead of Cl there is the ligand that is Cn, Cn is a strong field ligand and it will cause pairing in the d orbital. And then what will happen? One d orbital is empty there for the hybridization, as well as s and p orbitals are also available. It means in that case the hybridization that will possible is this way. And here is the pairing of electron pair due to the presence of strong field ligand. And now in this case, 1d and 1s and 2p orbitals will hybridize, and on that basis this hybridization would become dsp2. It means it is neither paramagnetic nor it has the shape tetrahedral. Its structure is not tetrahedral, that's why this is not following this condition. Further, if I talk about the next compound, this is of copper, CuCl4 2 negative. If I talk about this compound, in this compound the oxidation state of the copper is 2 plus. And what's the configuration in this case? In this case its configuration would becomes 3d9. And if its configuration is 3d9, that can be represented here. I'm just representing it here. D orbital, 1s orbital, and the p orbitals are here in this way. Now 9 electrons we have, so I'm just showing this in this way. Now for the hybridization there are s orbital, p orbital and d orbital also, as this Cl is a weak field ligand, and in this case this hybridization is sp3. One electron is unpaired, diamagnetic nature, structure is tetrahedral. It means it is also following this given condition. And on that basis, A and B are those compounds which are paramagnetic as well as tetrahedral complexes. And that's why the correct answer is A and B. That's why I'll choose this option 4 as the correct answer. After this, now question number 80. Crystal field stabilization energy of high spin complex cation having D5 configuration in an octahedral field is. It means in this question you just need to find out the crystal field stabilization energy delta naught for high spin complex with D5 configuration. It means the configuration in this case is D5, and as it is high spin complex, its configuration would be T2G3 and EG2. This would be the distribution of electron in T2G and EG level. And now we need to just find out delta naught. That would be equal to 0.4 into 3, because 3 electrons are there in T2G level. Plus in the EG level we can find out it 0.6 into how many electrons are there in EG level? 2 electrons. And if you solve this, you will obtain 0 value. And we can say that for D5 configuration in an octahedral field, crystal field stabilization energy is 0. And that's why option 2 is the correct option.